Now talking about the least squares method, so we know that we have x and y values, right? So x1 till xn and then y1 till y, and this is observed data, which basically means that this is, let's say, the data from previous years. So this is going to be, let's say, yeah, we have all that data. From that, like what our next task basically is to use this sample data and to determine the values of b0 and b1. So like if you remember from the previous video, we had y is equals to b0 plus b1x. So y hat, sorry, because y that is the estimated value of the sales. So y hat is equals to b0 plus b1x, and our job is to find the values of b0 and b1 using the data that we already have. Now this is just the estimated equation, right? The original model would be y is beta naught plus beta 1x. So like this would have actual values, the true values that we already know that happened, and those are true. And this here is just the estimation. So let's say that the estimation of ith element is given by this equation, and that this is the true value here. This is just the estimation that we are going to do using our values of b0 and b1, and this is why I is the actual value with beta naught and beta 1x. This is, we call it observed value, right? And our whole purpose is to find a model or find an equation which minimizes the difference between the actual value, which is yi, and the estimated value that we have, yi hat. Our whole purpose is to minimize this difference so that our model can come as close to the actual model that we don't know. So how is the least squares method useful in this? Because least squares method, what it does, it gives us the value of b0 and b1 such that it minimizes the difference between these. So it's not actually minimizing the actual difference between these two, it is minimizing the sum of squares of the deviations between the observed value and the estimated value. So what I just said can be put into an equation. So basically the least, let's just take the other one, the least squares criterion is minimizing the summation of differences between yi and yi hat squared. So yi here is the observed value of the dependent variable for the ith observation, and then yi hat is the estimated value of the dependent variable y for the ith observation. Getting here, we can do some math, which I don't know what it is, to find the values of b0 and b1. That is what we were trying to do here for now. So b0, actually b1 is the summation of xi minus x bar, yi minus y bar, over again xi minus x bar, so squared. So this is the value that we can get for b1, and b0 is going to be y bar minus b1 of x bar, which is basically we're just putting the value of b1 back into the equation and then singling out b0. So that's how we get b0. So this is a formula that can be used to find the values of b1 and b0. And since we have gotten both those values, that was the whole purpose of least squares model. So that's what it does.